All right, so today we're going to look at solving literal equations. Okay, so remember, our goal is still the same. We're still trying to get that variable all by itself. Okay, so if we look at number 1, it says solve t minus jk equals p for k. So the variable we're trying to get all on its own is k right here. So I'm going to go ahead and underline k. I need to get k all by itself, so I'm still using my inverse operations, just like if t or j were numbers. Okay. So I start from the outside and work my way in. So the first thing I need to get rid of is this t. The t is a positive t, so I'm going to subtract t from both sides. Oops, I didn't write that on the right side, did I? From both sides. These t's cancel out because if I have a t and then I take it away, I have 0 t's, so they go away. All I have left is negative jk is equal to p and t are not like terms, so I cannot combine them. So I just write it as p minus t. Now I'm still trying to get the k by itself. So the negative j and the k are being multiplied. Since those are being multiplied, I still do the inverse, which is division. So I'm going to divide both sides by a negative j. When I do that, the j's cancel out. Just like if it was a number, it still cancels out. And I'll have k is equal to, well, the p, the t, and the j still aren't like terms. They're all different. So I'm just going to leave it like that. P minus t all over a negative j. And that's going to be my final answer. Okay, so really we're still doing our inverse operations. We're just not canceling anything out. That's really the gist of it. All right, so looking at number 2, I have s times t divided by 9 equals v, and we want to solve for t. So t is the variable we want to get by itself. We notice that the whole thing is being divided by a 9, so the first thing I want you to do is I want you to multiply both sides by the 9 because that's the inverse. Okay, so I want everybody to go ahead and start that problem, and then you can check your work with mine when you're finished. All right, so I hope you try that one on your own. I gave you that hint of we're going to start by multiplying both sides by the 9. That's going to cancel, so then I'll have s times t is equal to v times 9 just gives me 9v. I'm still just trying to get that t all by itself. That's the goal. Okay, so the s and the t are being multiplied, so I need to divide those out. So I'm going to divide by the s. The s's cancel, which is great. That's what we needed. So all I have left is the t, which is also great because that was the goal, was to just have t by itself. Okay, so then I have 9v divided by s. Nothing over on this side has a like term, so I'm just going to leave it like that. Okay, so your answer you should have gotten was 9v divided by s. All right, if you have questions about those two, please let me know. Okay, I'm happy to help with those if you do. The last one we're going to look at is number 3. It says solve the equation for m, justifying each step on the right. So we're going to be using some justifications here. And we're solving for m. That's what we want to get by itself. Okay. So the very first thing we notice is we have a set of parentheses. And guess what? The m is in the parentheses. So I'm going to treat this like any other problem. And I'm going to distribute the 2m, or the 2 to the m and the n. So when I do that, I'll have 2m, because 2 times m gives me 2m. 2 times the negative n gives me negative 2n, plus 6y is equal to 4z. And in that step, I'm treating it just like any other problem, and I know I was using my distributive property. Remember, if you feel like I'm going a little too fast, you can always hit pause, rewind. All right, so now I'm still trying to get the m all by itself, and I have a lot of stuff going on over here on that side. Okay, so I need to get rid of this 2n, whoops, but not by erasing, I meant to highlight it. There we go. I need to get rid of this 2n, and I need to get rid of the 6y. So I'm going to start with the 6y. Okay, that's just what I'm going to do first. Okay, it's a positive 6y. Since it's a positive 6y, to get rid of it, I'm going to subtract it to the other side because that's its inverse. So, oops. Sorry, guys. So I'm going to subtract 6y from both sides. Those will cancel, which is great. That's what I wanted. So I still have 2m minus 2n equals 4z and 6y are not like terms, so I can't combine them. So 4z minus 6y. In that step, I was subtracting, so that's my subtraction property. So I still have that 2n over there with the 2m. I need to get rid of that one too. It's a negative 2m. We're subtracting it, so therefore I'm going to add 2n to both sides. Okay, those cancel, which is great. So now all I have left is a 2m, so that means I'm getting almost there, is equal to 4z, 6y, and 2n are not like terms, so I can't combine them. So I just have 4z minus 6y plus 2n. Okay, and in that step, I was adding. See how I added that 2n over? So therefore, I'm using my addition property. Remember, the property always is telling you what did you actually do in that step. Well, in that step, we added. All right, last step. I have that 2 with the m. The 2 and the m are being multiplied, so I'm going to divide out the 2. And I have to divide everything on this side by a 2. So the 2's are going to cancel out, so I just have an m. 4 divided by 2 gives me 2z. Negative 6 divided by 2 gives me negative 3y. And then 2 divided by 2 gives me plus 1n. And that's going to be my final answer. Well, in that step, forgot to tell what we did. We were dividing, so that's my division property. Alrighty, guys. So if you have any questions about those problems, please let me know. If not, you can move on to your assignment on Go Math. There's not a back to this set of notes that we're doing today, so you're good to move on to your assignment.